Now, one important application of remainder and factor theorem is that we can use that theorem to factorize a given cubic polynomial. So these are again very common questions asked in the exams. So the first question is, using the factor theorem, show that x minus 2 is a factor of the cubic polynomial, hence factorize the polynomial completely. So they're first asking to show that x minus 2 is a factor of this cubic polynomial. So let's say that the cubic polynomial is fx, which is x cube plus x square minus 4x minus 4. We are assuming this. Now, if I divide this cubic polynomial with x minus 2, if the remainder is 0, then it proves that x minus 2 is factor of this cubic polynomial. So according to factor theorem or remainder theorem, let's find out for what value of x the divisor x minus 2 is equal to 0. So if x minus 2 is equal to 0, that implies x has to be equal to 2. So let's evaluate the dividend when x equal to 2. So that is f of 2, and that is equal to 2 cube plus 2 square minus 4 into 2 minus 4. So this is equal to 8 plus 2 square is 4 minus 4 into 2 is 8 minus 4. 8 and minus 8 is 0, 4 and minus 4 is 0. So this is equal to 0. So since f of 2 is equal to 0, that means when I substitute x equal to 2 in the dividend, that value is 0. I will say therefore x minus 2 is a factor of the dividend f of x. So this is the first part of the solution. Now that we have found out that x minus 2 is a factor of the cubic polynomial, if I want to factorize the cubic polynomial completely, I want to find the other factors. And for example, if I had a number like 30, and if I want to find, let's say that I know that 3 is one factor of 30. If I want to find the remaining factors of 30, I can do 30 divided by 3. And the answer is 10. So I will say that 10 is also a factor of 30. And if I find that I can factorize 10 as 5 into 2, then 5 and 2 are also factors of 30. That's the logic that we are applying in this question. So now what we will do is we will try to find the other factor. So x minus 2 is a linear polynomial. If I divide that with my cubic polynomial, the quotient will be a quadratic polynomial. That's what I'm expecting. And we already know how to factorize a quadratic polynomial by splitting the middle term. So let's do the long division here. X minus 2 we are dividing with x cube plus x square minus 4x minus 4. So first term in the quotient will be x square, and I'll get x cube minus 2x square. This is minus, this is plus. When I'm subtracting, x cube is cancelled. 2x square plus x square is 3x square. Move this down, minus 4x. So the second term is plus 3x. So we will get 3x square minus 6x. Again we are subtracting. So now here we will get 6x minus 4x is 2x. And this minus 4, I'm moving it down here. So the last term will be plus 2. So we will get 2x minus 4. So that means after doing this long division, the cubic polynomial fx is actually equal to x minus 2 multiplied by the quotient, which is x square plus 3x plus 2. Now this quotient of the quadratic polynomial is x square plus 3x plus 2. I will be able to factorize it by using splitting the middle term, that method. So the constant is 2. That means product of two numbers I want as 2 and the sum of two numbers I want as 3. So if I look at some combination, 2 into 1 is 2 and 2 plus 1 is 3. So I can split the middle term 3x as 2x plus x. So this is x square plus 2x plus x. So we can now find common factors. X square plus 2x, common factor is x. And x plus 2, I will write it as 1 into x plus 2. So x minus 2 into x plus 2 into x plus 1. So this is the cubic polynomial factorized completely. So I should write the cubic polynomial as product of its linear factors. Now let's look at the next question to factorize the given polynomial completely using remainder theorem. Now the difference in this question is they have not given us any idea about any one of the linear factors. In the previous question at least we had some idea. So here we have to completely rely on trial and error. We have to find out a linear factor first. By substituting some values of x, we will be getting to know that. And it's not just any random value of x. We will not choose like any number like 0. We have to use non-zero numbers. It can be positive or negative. If I look at the constant here, it is plus 10. So let's think of some factors of 10. It is 1, 2, 5 and 10. So I will probably try to use some of these values to find out whether substituting x equal to some value like this will give me the result as 0. I can also use the negative values also. Now, if I look at the expression, everything is being added, everything is plus plus plus. So if I put x as a positive number, then the expression will definitely not be 0. It cannot be 0. So to make it 0, I have to choose a negative value of x. If I choose x equal to minus 1, you can do this in the rough work. Plug x equal to minus 1 in the expression, it is still not 0. But if I choose x equal to minus 2, I will get 0. So I have to write that and show. So let fx equals to this cubic polynomial. So f of minus 2, when I substitute x equal to minus 2, I will get 6 into minus 2 cube plus 25 into minus 2 square plus 31 into minus 2 plus 10. This is same as 6 into minus 8 plus 25 into 4 minus 62 plus 10 minus 48 plus 100 minus 62 plus 10. So 100 plus 10 is 110, minus 48 minus 62 is minus 110. So this value is equal to 0. So if f of minus 2 is equal to 0, I have substituted x equal to minus 2. That means x plus 2 equals to 0. So x plus 2 is a factor of the cubic polynomial. So I will say therefore x plus 2 is a factor of the cubic polynomial fx. Now after I know this, I can do my long division. So x plus 2 divided by 6x cube plus 25x square plus 31x plus 10. So doing this division, I will expect my quotient to be a quadratic polynomial, and that is another factor of this cubic polynomial, and then I can again split the middle term. So let's do the long division. 6x square, then subtract, so I will get then plus 13x so 31 minus 26 is 5, then plus 10, this will be 2, so 5 not 2, this will be 5, so 5x plus 10. So I will find that my cubic polynomial is equal to x plus 2 multiplied by this quotient, which is 6x squared plus 13x plus 5. Now I will again try to factorize the quadratic polynomial by splitting the middle term. So 6 into 5 is 30. I need product of two numbers as 30 and the sum of the two numbers should be 13. If I try some combination, 10 into 3 is 30, 10 plus 3 is 13. So the middle term splitting will be done like that. 6x squared plus 10x plus 3x plus 5. Then taking common factors, 2x, I will get 3x plus 5, and I can write this as 1 into 3x plus 5. So therefore finally I'll get x plus 2 into 3x plus 5 into 2x plus 1. This is the cubic polynomial factorized completely.